Okay. See here. All right, so, I was trying to remember, did we do these problems? We did it? Okay, good, so that means we did this one? BMI?
Yes.
Okay, all right. Okay, so we're almost finished with this chapter. The only thing that is left for us to discuss is density. And I'm quite sure we're familiar with that concept, density, which is a physical property oftentimes used to identify or help to identify a particular substance. And we all know what the density is by definition. It's a ratio of mass to volume. And we can express that definition according to this equation right here. And it turns out that you can actually use density as a conversion factor to convert from mass to volume or volume to mass, right? And I think I have an example here. Let's say you have a liquid methanol, which has a density of 0.791 gram per mil. There are two factors that we can use. We can use this factor here, conversion factor that is, or this one, depending on what we're trying to achieve. So if you want to convert from volume in mils to grams of methanol, you use this equation. If you want to do the reverse, if you want to go from grams to mils, then you use this conversion factor. All right. So for example, oops, we copy this. Okay, so you're given this question. It says a beaker has a mass of 85.2 grams when empty, and 342.4 grams when it contains 325 mils of liquid methanol. So the question is, what's the density of methanol? Well, in this case, we know that density is equal to mass over volume. We already know what the volume is. It's 325 mils. What we don't know is the mass, but we do know, at least not directly, we don't know what the mass is directly. But we know that the mass is 85.2 grams when empty, and then when you put the liquid in it, it's 342.4 grams. So therefore, we know that the mass will be the difference between those two. So that's 342.4 grams minus 85.2 grams. And then we divide that by the volume, which is 325 mils, right? So if we were to work out the numerator part of this, it would be 342.4 minus 85.2, and that gives you 257.2 grams, and then we divide it by 325 mils. And according to my calculations, you have to round this off to 3 sig figs, which would be 0.791 grams per mil. That's how you do that, all right? Any questions about it? Questions?
Round of 4, 6 things, since 342.4 is but it's 4 digits.
I'm sorry, read that?
Do you round of 4, 6 things, since 342.4 is 4
No, you're talking about here?
yeah.
Well, when you're subtracting or adding, you have to round off your answer to the lowest number of decimal places. So this has 1 decimal place here. This has 1 decimal place here. So that means that this has to be expressed to 1 decimal.
Okay.
Right. And then when you divide, you round off according to the lowest number of significant figures. Which in this case, dividing this by this has 3 sig figs.
Okay.
Right, and this has 4 sig figs.
Okay.
So the final answer must be expressed in each sequence.
Okay. Anyway.
Right? Okay, any other questions about this? Any other question? All right, let me get rid of it here. Okay, the next question. How many kilograms of methanol does it take to fill a 15.5 gallon fuel tank? How do we do this? Okay, so. The first thing I would do is, I would start off with the 15.5 gallons. Right? And then, I'll try to convert the gallons to milliliter, which means I have to consult the table here. So let me go. Okay, so here is the table. And the particular page is this one. Okay. So, let's see what we can work with here. Okay, so here I see 1 gallon is equal to 3.7854 liters. So what I would do is I would multiply this by I'll multiply this by 3.7854 liters over 1 gallon. Right? And then the next step would be to convert from milliliters to liters, or I should say the other way around, from liters to milliliters. So that would be 1 liter down here. I'm sorry, 1 liter down here and 1,000 milliliters above. And then I'll multiply this by the density, which is 0.791 grams per milliliter. But remember, the question is asking for the mass in kilograms. So that means that there's one more conversion factor that I'm gonna need, and that would be 1 kilogram above, 1,000 grams below. And that would be the setup because the gallons will cancel out here and here, the liters will cancel out here and here, milliliters will cancel out here and there, grams will cancel out, so the final answer will be expressed in kilograms. So now we have to do the number crunching, 15.5 times 3.7854 times 1,000 times 0.791 divided by 1,000. And according to my calculation, now I need to roll this out to 366. So according to my calculation, that would be 46.4 kilograms, right? And I don't know if I told you this before, but please, when I'm doing these calculations, please do them with me so that, you know, we're all on the same page. I might be making a mistake and you can catch it and so on. All right, any questions about this one? Any questions? Any questions? Okay, any questions on there in Zoom? All right. So yes, that's it for this chapter. So now we can I didn't give you assignment number 1. All right, so let me do that now. And go. Down. You. You're going down. 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 And for you guys out there in Zoom, let me see if I have that published. so that you guys can have access to it as well. Okay, so let me. Awesome. Good. Okay, so I have published assignment one. Yes. All right, now for the first part, I'm going to leave you guys to answer those questions on your own. Should be easy. For question number one, that is. I want to jump to question number two. So question number two says, that you have a star and the mass of the star is 2.0 times 10 to the 36 kilograms. And it says, assuming it to be a sphere of average radius of 6.96 times 10 to the 5 kilometers, calculate the mass of the star in milligrams, the A part, right? I'm sorry, yeah, milligram, wow. That would be a huge number. I can already tell. So to do that, start off, of course, with what you're given, which is 2.0 times 10 to the 36 kilograms. And then what I would do is convert that to grams first, right? So 1 kilogram is equal to 1,000 grams, right? So the kilogram units will cancel out. So you're left with the gram unit. And then we'll take it another step further to convert from grams to milligrams. So 1 milligram is the same thing as 10 to the minus 3 grams. So to express that here, I would put the 10 to the minus 3 grams down here and the 1 milligram above, so that this gram unit will cancel with that. And then we do the number crunching. So that's 2 times 10 to the 36 times 1,000 times 1,000. And according to my calculation, hold on, wait a minute, that is something. Okay, so according to my calculation, this works out to be 2.0 times 10 to the 42 milligrams. All right. And just to note, because you have two sig figs here, and you have exact relationships here and here, that means that your final answer will be rounded off to 2 sig figs. All right. Okay, any question about this? Yes, sir.
The second part of the second sentence have anything to do with our question? It gives us number about a sphere, like the.
No, that has to do with the B part,
Okay.
right? Because the B part, right, B part gives you the formula for the volume of a sphere, and that is what you're going to need in order to answer it. You're going to need that information, the average radius. Okay, so let me clear this here. And scroll down. So the question is asking for the volume, right? So they gave you the formula for the volume. V is equal to 4/3 pi r cube. So basically it's a matter of plugging these numbers in. So in this case, B will be equal to 4/3 times pi, and the radius of the star is 6.96 times 10 to the 5 kilometers, right? Cube. Right, so let's see what this gives. What I'm going to do is work out what's within the parentheses first. So that would be 6.96 times 10 to the 5. And then I need to cube it. And then I multiply that by pi. And then I multiply that by 4, divided by 3. And according to my calculations, again, you have to round up the piece of things. So that will be 1.41 times 10 to the 18. And the units here will be kilometers cubed, which is what the question is asking for. Okay. Any questions? Okay, let me clear this. And then the C part is asking for the density. Well, that's relatively easy because you determined the mass earlier and the volume in the B part. So basically you divide the mass by the volume. So if I remember correctly, to calculate the density, the mass of this star we calculated was 2.0 times 10 to the 42 milligrams, I'm sorry, divided by the volume which we just did, which was 1.41, what was it? 1.41 times 10 to the what? What was it?
18.
10 to the 18. And that would be in kilometers cubed. So the question is asking for the densities in milligram per kilometers cubed. So that's 2 times 10 to the 42 divided by 1.41 times 10 to the, oops. Okay, this is 2 times 10 to the 42 divided by 1.41 times 10 to the 18. And when I did that, rounding off to 2 sig figs, that works out to be 1.4 times 10 to the 24. And the units here would be milligrams per kilometers cubed, which again is what the question was asking for. Right? The question about this one? Questions? Okay.
How'd you get the 1.4 again?
Because, well, when I did that, I got 1.418 and some other digits. But I have to round this out to 2 sig figs because this is 2 sig figs right here. 2.0.
Yeah.
And then this is 1.41. So I have to round out to the lowest number of siblings. Right?
Well, this time, does you care about like what kind of ink we use for our, like what color?
Preferably blue or black ink. And the reason why is because you're going to submit these online. And I find that sometimes when students write in pencil, when I receive it and print it, it comes out very faint, right? So I would prefer that you do so in ink, blue or black, right?
Okay.
Okay, okay, let me clear this. And scroll down. Okay, so basically you're given some calculations to do. And your final answer must be expressed in the correct number of sig figs or decimal places, depending. All right, so I don't know if I mentioned this before, but if you have a situation, well, firstly, let's remind ourselves of the rules for rounding off, right? So basically, when you're multiplying and or dividing, you're going to round off your answer to the lowest number of significant figures. But when you're adding and or subtracting, you're going to round off your answer to the lowest number of decimal places, right? So that's the difference between those two. Now, if you have a situation where you have, and I think I gave an example of this earlier. If you have a situation where you're carrying out a series of calculations where the rules are different at each stage, right? Then what you have to do is work on each stage and round off accordingly, right? So for example, if you have, let's say, a division earlier and then a subtraction later, then when you do the division, you round off to, according to the lowest number of sig figs. And then when you do the subtraction, you round off according to the lowest number of decimal places, right? And in fact, this question here is an example of that, because basically what you need to do first is round off what's within the parentheses here, right? So let's see what I get. 25.27 minus 24.16. And according to my calculation, that part works out to be equal to 1.11. 1.11. So now we have to multiply 1.11 by 100.62 times 4.184, right? So now we have to look at what happens when we multiply. Remember, when you're multiplying, you round off according to the lowest number of significant figures, right? So this has 3 sig figs, right? This number here has 5 sig figs. And this number here has 4 sig figs. So whatever the calculation that results, you have to round off to 360, right? So I'm going to multiply the 1.11 by 100.62 by 4.184. And according to my calculation, I got 467.3034288. But we have to round that off to 3 sig figs, so that becomes 467. And that would be how that is done. All right? Any questions about this one? Okay, so if you understand this one, how would you tackle this problem here? Now, one thing I neglected to mention, which didn't apply to the first question, but you should take note of this. Assume the numbers in bold type are exact numbers, right? So that's a very important, thing that you have to take into account when answering these questions. There are no bold numbers in the first one, so it does not affect our answer here. But for this one, it does, because the 100 is in bold type, right? So, how would you tackle this problem?
Let's round it to the nearest whole number. Let's multiply by. Like when you get to the final step and multiply by 100, you have to round.
100 doesn't count.
No, the 100 is exact. So therefore, you don't use that to determine the extent to which you round off your final answer.
So,
What I would do first is work out what's within the parentheses first, right? So I would work out this part here first. All right? So let's do that. 8.925 minus 8.944. And what I got, and correct me if I'm wrong, but what I got for this part is 0.021. Now, when you're subtracting, you round off to according to the lowest number of decimal places. You have 3 decimal places here, 3 decimal places here, and also 3 decimal places here. So we don't need to do anything as far as that is concerned. Okay, so now that we have done that, what's the next step? You're going to divide the 0.021 by 8.925. Okay, now when we do that, we have to round off according to the lowest number of sig figs, which in this case, when I did that, I got, rounding off to the lowest number of sig figs, I got 2.4 times 10 to the minus 3. All right, so that's what all of this gives you, right? Then you multiply by 100, right? So when I multiply that by 100, I'm gonna get 0.24. And remember, the 100 is exact, so therefore, basically, you round off to 2 sig figs to get the final answer. Right? That's it. Any questions about this one? Any questions? All right. Okay, let me clear this here. Okay, how would you deal with this one? Again, remember the bold type numbers are exact, all right? So what would you do in this case? I'm sorry?
The parentheses.
Okay, so
Start.
9.04 minus 8.23 plus 21.954 plus 81.0. Okay, I got, when I work out this part here, I got 103.764, but we need to do some rounding here, right? So how would you round this number? Not 6 figs, remember you're adding and or subtracting. So you'd have to round off to the lowest number of decimal places, right? So what's the lowest number of decimal places we see here of the numbers in the parentheses? 1, the 81.0. There's only 1 decimal place right there. So that means you have to round off the 103.764 to 1 decimal place. So when you do that, it rounds off to 103.1. 8, exactly. So now we got this, rounded off to 1 decimal place. We have to divide that now by the 3.1416. So let me do that. 103.8 divided by 3.1416. And I got 33.04048892. However, we need to round this off to how many sig figs? 4 sig figs, exactly. So when rounded off to 4 sig figs, I got 33.04. And that would be the final answer. Right? Any questions about this one? Any questions? Any questions? All right. B, again, 9.2, that's exact, right? So what would you do in this case? I'll work on what's in the parentheses first, right? So 9.2 times 100.65, right? And when I did that part, the right over what I got 925.98, right? However, we need to round that off, right? Actually, we don't, because the 9.2 is exact. And here we have 5 sig figs, right? So that means that this answer must be expressed to 5 sig figs, which it is already, so we don't need to actually round it off, right? So the next step is what? Now that we have this number here, which is 5 sig figs, what do we do next? Divide by?
8.321.
Exactly. Now here we have to round off because we have 5 sig figs here. And we have 4 sig figs here, right? So how would you round off your answer? Whatever you do. You round off to what? Well, how many sig figs? That's what I meant to ask. 4 sig figs. All right. So let me do the calculation. So 925.98 divided by 8.321. And you round off, okay, so I got 111.282, blah, blah, blah. We need to round this off to 4 sig figs, so that would be 111.3. And that's how you do that. All right? Any questions about this one? Any questions? All right, so this is basically what you need to do whenever you're doing calculations. You have to make sure that you round off appropriately, especially when you have multi-step processes. And the rules will be different for each step. So you have to apply the rules in each case so that you get the right answer corrected or rounded off to the correct number of segments. Okay, let me clear this first. And let's go down. Okay, how many inches are there in 45.6 centimeters? So, and they gave you information, which is actually in the table, but it's provided here. So how would you go about solving this problem? Let me hear some ideas. Yes, ma'am.
You do 45.6 centimeters.
Okay.
And then you divide that by 2.54 centimeters,
Uh-huh.
the 1 inch on top,
Uh-huh.
in that case without your.
So the centimeters units will cancel. Now, in this particular case, this is the exact. And how many sig figs do we have here?
3.
Exactly. So that means that whatever answer you get here, you have to round out to 3 sig figs, right? So 45.6 divided by 45.6 divided by 2.54. And okay, so what I got is 17.9527559. So how do we round that off to 3 sig figs? 18.0 is indeed correct. Very good. That's how you do it. Right? Any questions about this one? Any questions? Questions? All right, the next one. How many centimeters are there in 1.23 times 10 to the minus 6 kilometers? So you're given 1.23 times 10 to the minus 6 kilometers, and you're asked to convert to centimeters. So how would you go about that conversion? What would be your first step?
But you need to figure out how many centimeters are in 1.
Okay. How will you determine that? Okay, so you have to go to the chart. And the chart that you'll be using is the chart with the prefixes. You have to know what kilo means and what centimeter means. I mean, what centimeters. Kilo and centimeter. So let's start off with the kilo. What's the relationship between kilometers and meters? Right, so basically we can express that as 1,000 meters over 1 kilometer, right? So that this goes with that, right? Then the next relationship now is between the meters and centimeters. What's the relationship between the meter unit and the centimeter unit? Yes, ma'am. 100 centimeters equal to 1 meter, and the way that you express that here is 100 centimeters would go above, and 1 meter would go below, so that this cancels out with that, and then you do your calculation. So 1.23 times 10 to the minus 6, multiplied by 1,000 times 100, and according to my calculations, this works out to be 0.123 centimeters. That's all that is done, right? Any questions about this one? Questions? Okay. You clear this? Okay, how many hours are there in 34.5 years? Let me hear your ideas about solving this one. Let me start you guys off with the 34.5 years, right? So you're going from years to hours, right? So let's see what units you can get, I mean, in between going from years to hours. So what would you do first? Go from years to what?
Days.
Days, okay. And then from days to? Hours, exactly, right? So let's start out with the first step. How will you go from years to days? What goes up top here and what goes below here? 365 days over 1 year, so that this cancels with that. So we have the days, and then how do we go from days to hours? 24 hours over 1 day, and that's it. 34.5 times 365 times 24, and we have to round off to 366, right? This is what I got. Let me write it down. 302,220 hours, right? But we have to round this off to 366. So how will you round this off to 366?
302 plus 3.
Okay. Or if you want to, this is ours, or if you want to express it in scientific notation, that would be 3.02 times 10 to the 1, 2, 3, 4, 5, 10 to the 5 hours. Right, that's it. All right. Any questions about this one? Any questions? Okay, number 7. How many inches are there in 355 millimeters? Right, so we're going from millimeters to inches. All right. So how would you do that? Right? I don't think the chart has a direct relationship between them. It may, I don't know.
Nearest closest relationship.
Right.
Centimeter.
Right, so I will go from millimeters to centimeters because, and then from centimeters to inches, because we know that relationship. That is definitely in the chart. So what I will do first, to go from millimeters to centimeters, 10 millimeters will be equal to 1 centimeter. So you're going to have 1 centimeter above as the numerator, 10 millimeters below as the denominator. Those units will cancel out. And then now the next step is to go from centimeters to inches. And we know that for every 1 inch, there are 2.54 centimeters. So let's see what that gives. 355 divided by 10, divided by 2.54. And according to my calculation, now this I have to round off to 3 sig figs. So according to my calculation, when rounded off to 3 sig figs, the answer would be 14.0 inches. All right? Any questions about this? Any questions? All right, let me clear this. Go down. How many milliliters, I'm sorry, how many milliliters are in a cubic meter? And they gave you this right here. So they gave you 1,000 liters in 1 meter cube, which is a cubic meter. So they're asking how many milliliters are in 1 meter cube, right? Now, in this particular case, since they gave you this relationship, you can go from meters cube to liters, right? Based on this relationship here. And then now, because the question is asking for milliliters, you can go directly from milliliters, I'm sorry, from liters to milliliters, right? So 1 meter cube multiplied by a conversion factor which represents this relationship, which would be down here, I'm going to put 1 meter cube, and up here I'm going to put 1,000 liters. And then now, to go from liters to milliliters, we know that 1 liter is equal to 1,000 milliliters. So this will cancel out with that, this will cancel out with this, and then we do the number crunching. Let's see what this gives. Oh, that's easy. That's 10 to the 6 milliliters. All right, and that's it. Any questions? Okay, number 9. Here it is. Says, how many miles are there in 3.44 times 10 to the 8 inches? 3.44 times 10 to the 8 inches. And we're trying to get from there to miles. Okay, this is it. Oh, actually, this helps. It says there are 0.61 miles in 1 kilometer. So, but still we have to go from inches to miles. So, okay, so one way of doing it, there are multiple ways of doing it, but since they gave us this, what I would do is I would go from, let me do it up here. I would go from inches to centimeters, because we know that 1 inch is equal to 2.54 centimeters. And then I'll go from centimeters to meters, and then from meters to kilometers, and then kilometers to miles, because of this relationship that they gave us, right? So we're gonna need a series of 1, 2, 3, 4 conversion factors, right? So the first conversion factor allows you to convert from inches to centimeters. So that will be 2.54 centimeters is equal to 1 inch. So this goes with that. And then from centimeters to meters, we know that 100 centimeters is equal to 1 meter. So like that. And then we can go from meters to kilometers. 1 kilometer is equal to 1,000 meters. So we're going to put 1 kilometer here and 1,000 meters here. And then finally, we're going to use this value right here, because that tells you that it's 0.61 miles in 1 kilometer. And that's it. So centimeters will cancel out, meters will cancel out, kilometers will cancel out. So your final answer would be in miles, right? So let's do the number crunching. 3.44 times 10 to the 8 multiplied by 2.54 divided by 100 divided by 1,000 times 0.61. And according to my, let me see here. Okay, so in this case, we need to round off to 2 sig figs. And the reason why is because this relationship here is not exact, right? So we have two sig figs here to work with, right here. Right? Even though we have three sig figs here. Now, let me explain something. I don't think I discussed this last time. When it comes to certain conversion factors, some of them are exact relationships and some are not. All right? And well, let me work this out first and then I'll go further into that explanation. 3 point. Four. Oh shoot, what did I do? Times 0.61. Okay, so I'm just going to round off the two sig figs here. That would be 5,300. And this will be math. Now, let me explain what I was about to talk about with respect to certain conversion factors being exact and others are not. If you're converting from some metric value to another metric value, right? Then that would be an exact relationship, right? So if you're converting like from kilograms to grams or centimeters to meters, then those conversion factors would be exact. The same is true if you're going from non-metric to non-metric, right? That is also exact, right? Now, if you're going from metric to non-metric, right? Then that would not be exact, right? But there's one exception to this. And the exception is going from centimeters to inches or vice versa, right? Because 1 inch is exactly equal to 2.54 centimeters, right? So even though this is non-metric and this is metric, that's an exact relationship. But all other situations where you're going from metric to non-metric or vice versa, those are not exact relationships. So you have to take that into account when you're rounding off, which is what I did here. This is non-metric, that is metric, right? So that's the reason why I rounded this answer off the two significant figures. What time is it? 1:50. Okay. All right. Okay, any questions about this? Any questions? All right, so let's look at the last question. No, I don't think that's the last question, but the next question. Let me clear this here. Okay, so this question is talking about a waterbed, and it gives you the dimensions of the waterbed, and it gives you the density of water, and the question is asking for the mass in kilograms of water that you will need to fill this bed, right? So they gave you the dimensions, the length, the width, the height, and they gave you the density. And the question is asking for the mass of water in kilograms that you need to fill this water bed. So the formula that comes to mind immediately is the formula that relates the density to mass and volume. Of course, that formula is density is equal to mass over volume. What the question is asking for is a mass, right? So if we rearrange this equation, you're going to get mass is equal to the density multiplied by the volume, right? So they gave you the density already, which is 1.00 grams per centimeters cubed, right? Now, to get the volume for something with these dimensions, the volume will be obtained by multiplying this by this by this, right? So I'm going to do that here. 8.0 feet multiplied by 7.0 feet multiplied by 0.75 feet, all right? Now, here's the problem. There's some sort of incompatibility with the units, right? Because you have centimeters cubed here, and feet times feet times feet will give you feet cubed, right? So how do we deal with that? Not only that, but the question is asking for the mass of the water in kilograms. We have a mass unit here of grams, so we have to do some conversion here as well. Okay, so let's deal with the converting from feet cube to centimeters cube, right? Now we know that we can go from feet to inches to centimeters, right? We know that there are 12 inches in 1 foot, and we know that there are 2.54 centimeters in 1 inch, right? So this is how we're going to deal with converting from feet cube to inches cube, because feet times feet times feet, or I should say foot times foot times foot, gives you feet cube, right? So how do we deal with that? We multiply by 1 foot down here as a numerator and 12 inches up top as a denominator. But you have to do this. You have to cube that conversion factor, right? So that the foot cube unit will cancel out with the foot cube unit here. All right? Then we have to convert from inches cube to centimeters cube. Now we know that there are 2.54 centimeters in 1 inch. So we're going to put 1 inch down here and 2.54 centimeters above. And again, we have to cube that so that this inch cube unit will cancel out with that inch cube unit. So what we have done so far is successfully convert from feet cube to centimeters cube. And guess what? This centimeter cube unit will cancel out this centimeter cube unit, right? So we'll be left with the answer expressed in grams. But again, remember, the question is not asking for the mass in grams. It's asking for the mass in kilograms, right? So how do we get from grams to kilograms? We have to add another conversion factor, right? Where we have 1 kilogram above and 1,000 grams below, so that this cancels out with that. So therefore, whatever you get as your answer, it will be in the required units of kilogram. So let's see how the math works out. 8 times 7 times 0.75 times 12 cubed times 2.54 cubed divided by 1,000. Okay, I think I did something right. Let me just see.
Forgot
I'm sorry?
your 1 gram per centimeters cube.
Well, that shouldn't affect it. I think I made a mistake somewhere else. Let me try this again. 8.0 times 7.0. Oh, I think I know what I did. Okay. 8.0 times 7.0 times 0.75. And then I multiply by 12 cubed. And then I multiply by 2.54 cubed. And then I divide by 1,000. And I get a long string of digits, but I need to round off to, okay, what's the lowest number of sig figs involved? 2 sig figs, right? So I need to round this off to 2 sig figs. And when I do that, I end up with 1.2 times 10 to the 3 kilograms as your final answer. All right? Any questions about this one? Any questions? Questions? Any questions out there in Zoom?
No, you're good, sir.
Okay, thanks. All right, can I clear this? And let me scroll down. Okay, so this one talks about an oil slick. Spreads on water to form a thin film of 120 nanometers. And it says how many square kilometers of ocean will be covered by the slick formed when 2 barrels of oil are spilled. All right, and it gives you that 1 barrel is equal to 31.5 gallons. All right, so let's use our imagination to create a picture of what we have here. So basically, you have the oil spreading, right? So basically, there will be an area of oil on the ocean that you're trying to calculate. It tells you that the thickness is 120 nanometers and the volume would be 2 barrels, and each barrel is worth 31 or is equal to 31.5 gallons. So this is what I'm gonna do. I'm gonna start off with the 2 barrels. I'm gonna say 2 BAR. And what I'll do is find out how many gallons are in 2 barrels. So based on this equation here, it's 31.5 gallons over 1 barrel. All right. And then now what I'll try to do, okay, how shall I do this? This is gallon, right? I would convert, I'll try to convert the gallons to some metric unit. I know. I'll try to convert the gallons to kilometers squared. I'm sorry, kilometers cubed. That's what I'm going to try to achieve. So that means I have to more than likely do a series of conversion factors. So let me go to the table. Where's the table? Okay. So let's see here. Okay, let's see, gallon. Okay, the only thing I see here is 1 gallon is equal to 3.7854 liters. So let me put that as a conversion factor. 1 gallon is equal to 3.7854 liters. All right. So far, the barrel units cancel out, the gallon units cancel out, so we end up with the liters unit, right? And now, what would I do? Let's see. Yes, sir.
I can transform liters. Liters cube, maybe
Convert liters to,
meters cube,
okay, so what's the relationship between the liter unit?
1,000 liters is
1,000 liters is equal to,
1 meter cube.
okay. Is that shown here?
Well, one of the problems. Problem 8.
Okay, I think you're right. Yeah, you're right, actually, yeah, okay. So far, so good, so basically, the liter units will cancel out, all right? And then now, to go from kilometers, from meters cube, to kilometers cube, I would do this. 1 kilometer is equal to 1,000 meters, right? But I would cube this, right? So that this will cancel out with that. Now, here's the thing. What we're talking about here is the volume, right? And to get the area, I don't know if you're familiar with this equation from your math or trigonometry or whatever you call it. The volume of an object would be equal to its area multiplied by the thickness, right? If you're thinking about an object like the oil spreading on water, this would be the relationship between the volume, the area, and the thickness. What the question is asking for is the area, which is the volume divided by the thickness. This is the volume that we have here. So to divide that by the thickness, that would be 120 nanometers, right? Which we'd have to convert to kilometers. So 1 nanometer is equal to 10 to the minus 9 meters. And also 1,000 meters is equal to 1 kilometers, right? So here's where you're going to see the units canceling out. Already, we know that we're going to end up with kilometers cube up here. Here, the nanometers will cancel out with that. The meters will cancel out with the meters here. And this kilometer here will cancel out the kilometer cube up here. So if I put cube here and cube here, it's going to cancel out one of these 3 to leave kilometers squared. So your final answer will be in kilometers squared when you do all of that, all right? So let me do the calculation here. 2 times 31.5 times. Again. 2 times 31.5 times 37. 3.7854 divided by 1,000. And then I'm going to multiply by or divide by 1,000 cubed. And then I'm going to divide that by 120 times 10 to the minus 9 divided by 1,000. And when I did, oh no, I did something wrong here. This can't be right. This is too small a number. All right, let me do this again. 2 times 31.5 times 3.784 divided by 1,000. I think I know what that is. I forgot to cube the 1,000 that I divided. Okay, so the answer I got is 1.987 and some other digits. Now, to what extent do we need to round this off? Now, this here is an exact number, so we can't round out to that extent. And okay, so we have 3 sig figs, 4 sig figs. That's exact, that's exact, that's exact. Okay, so basically 2 sig figs, right? So when I wrote this out, 2 sig figs, I got 2.0 kilometers squared. That's how you do it. Right? Any questions about this one? Any questions?
Yeah, a question on like, once we get the 0.238 or 802, the first part, how will we?
I'm sorry, repeat that?
So once we get 0.2384 from combining like all the numerators, how we have to get the other back of the denominator, the area.
Well, if I understand what you're asking, you get the area, you divide the volume by the thickness. So the top part here is basically the volume, and you're trying to get the volume in kilometers cubed.
Okay, oh, do we just divide this number by the nanometer or?
Right, you have to divide by the nanometer, but you have to convert the nanometer value to kilometers,
Kilometers?
because you want to get the answer ultimately in kilometers squared.
Okay,
You know what I'm saying? So that's the reason why I went through all this trouble. The top part, you want to get it expressed in kilometers cubed. Bottom part, you want to get it expressed in kilometers. So that when you do the math, your final answer will be expressed in kilometers squared. Okay, any other questions about this? Any other questions? Okay, can I clear this? All right. And let's see what comes next. Oh, that's it. That's the last question. Okay. So make sure you make sure that your assignment is presentable. What I'm going to do now is open up a Dropbox for that assignment. Oh shoot, okay, I need to figure all this here. Today is the okay, so basically I'm going to leave the deadline date as Thursday, right? Let me go down here. Oh, wait a minute. Okay, so that's it. That's the assignment is gonna be due on the 28th, which is Thursday, right? So make sure that you upload it. Make sure it's in a PDF format. There's some other things, I don't think I've told you guys. Some other things that you probably need to do when you're uploading your assignment. Make sure you write your name at the top of the page. Make sure it's done in blue or black ink, because otherwise you run the risk of by the time I get it and I try to print it, it might be unreadable due to fakeness. What else? I think that's it for now. I'm going to basically post an announcement which outlines exactly what I expect in terms of the submission of all your assignments, all right? Okay, so in the time that we have left, I'm going to start with chapter 2. Then after that, I'll call it a day. And again, as I said before, a lot of this would be a bit of a review from what you learned in intro for high school chemistry, right? All right, so atoms, molecules, and ions. First, we're going to talk about are some laws which you should have met before. The first of which, some laws of chemical combination. First of which is the law of conservation of mass. And basically what this law says that the total mass remains constant during a chemical reaction. In other words, matter cannot be created or destroyed in a chemical reaction, all right? Whatever the mass of the product that you end up with will be equal to the mass of the reactants that you start off with. And then this law is the law of definite proportions, right? And what this law says that all samples of a compound have the same composition. Or another way of stating it, all samples have the same proportions by mass of the elements presented, all right? So here's an example here of a compound. I think this is copper, if I'm not mistaken, copper 2 hydrogen carbonate. In any case, what they're saying here is that wherever you find this compound, the percentage of carbon to copper to hydrogen to oxygen is fixed, all right? And that is true for compounds. The proportions are the same. If you get 2 samples of the same compound and they have the same proportions of the different element, that is to be expected because that's what the law of definite proportions says, all right? Okay, so let's look at this question here. It says the mass ratio of oxygen to magnesium in the compound, magnesium oxide, is 0.6583 to 1. So the question is asking, what mass of magnesium oxide will form when 2.00 grams of magnesium completely converts to magnesium oxide by burning in pure oxygen? So basically, what the question is asking for is the mass of the product. They gave you the mass of the magnesium, it's combining with the oxygen, right? And they gave you the ratio of the oxygen to magnesium, which is right here. So the first thing I will do is I will start off with the 2.00 grams of magnesium. Oh, shoot. Okay. I would find out the mass of oxygen that would react with it. So 2.00 grams of magnesium. I will multiply this by, since this is the ratio, 0.65 0.6583 grams of oxygen per every 1 gram of magnesium. So let's see what that gives. 2 times 0.6583. And that gives 1.316. 6, I'm sorry, 1 point. Yeah, okay, so this would be the grams of oxygen, right? That would be, reacting with this much magnesium. So the total mass of the magnesium oxide form, would be equal to the 2.00 grams plus the 1.3166 grams. And whatever that gives, that would be 3.3166 grams. That's it, right? Any question about this one? Okay. Moving on. Okay, law of multiple proportions. Basically, it's a bit wordy, the law that is expressed in words. But basically what this law says, let me just read this out to you and then try to explain what it's all about. When two or more different compounds of the same two elements are compared, the masses of one element that combine with a fixed mass of the second element are in the ratio of small whole numbers, all right? So what do they mean by that? Let's use this example right here. There are two compounds that would form when carbon reacts with oxygen. One of them is carbon monoxide, the other one is carbon dioxide, right? Now, if you take samples of those two compounds where the mass of the carbon is fixed, right? Like in this case, 3 grams of carbon in carbon monoxide, 3 grams of carbon in carbon dioxide. What you'll find is that the ratio of the oxygen that combines with each of them to form the respective compounds would be a simple whole number ratio. In this case, the whole number ratio would be an 8:4 ratio, which would be a 2:1 ratio, right? So that is basically what you'll find in the formation of compounds or different compounds formed from the same element. If you keep one mass fixed or one of the elements mass fixed, then when you compare the masses of the other elements, the masses will be in the form of small whole ratio numbers, right? So that's basically what this law is all about. So you can see that not only in the case of carbon dioxide compared to carbon monoxide, you can see that, for example, when you compare, let's say, in fact, I think I have some examples on the next page. Here we go, nitrogen, right? Combining with oxygen will form different compounds, right? So this example here, we're starting off with 28 grams of nitrogen, and in one case, it will react with 16 grams of oxygen to form compound 1. Compound 2 will be formed when it combines with 48 grams of oxygen. Compound 3 will be formed when it combines with 64 grams of oxygen. And compound 4 is formed when it reacts with 80 grams of oxygen. So you'll notice here, right, that for 28 grams of nitrogen, which is fixed, we'll combine with these masses to give these different compounds. And if you look at these masses, it's in the form of whole number ratios, 80 to 64 to 48 to 60, right? And that falls in line with what we observe in the formulas for these compounds. So compounds 1 through 4 are these compounds here. If the nitrogen is fixed, as it is in these cases, then the ratio of oxygens in the different compounds will be 1 to 3 to 4 to 5, which is basically the same as what we see here. If you compare the ratio of the oxygen combining with nitrogen to form these compounds, all right? So that's another example of the law of multiple proportions. All right, I'm going to stop here for today, and we'll continue this discussion on Thursday. Okay, and you guys out there